welcome to space. So currently we are sitting quite a long way from the sun, just watching all the planets orbit. The time is, well, it's moving very quickly at the minute. I'm speeding up time so that so you can actually see the orbits of the planets. Now the sun is an example of a star. It's the star at the centre of our solar system. All of the planets orbiting it. It provides light and heat for all of the planets in the solar system, and it enables life on Earth to exist. So if I zoom out, you can see the planets orbiting. So we've got the terrestrial planets here, the 4 rocky planets: Mercury, Venus, Earth and Mars. Something I want you to notice actually is how is Mercury's orbit different to Mars's orbit? Yeah, so Mercury's orbit is clearly much closer to the sun. Mercury clearly orbits way closer to the sun than Mars does. As a result of that, it actually has to move much quicker as well. So the speed, Mercury's speed, is much faster than Mars's speed. Let's have a look. Mercury's speed, well, because it's not exactly a circular orbit, it's not a perfect circular orbit. It orbits, its velocity changes. Its velocity changes, it fluctuates between about 38 kilometers every second to about 60 kilometers every second, whereas Mars's orbit is, well, it's somewhere around 25 kilometers every second, 26 kilometers every second. So it's much slower. Doesn't have to orbit quite as quickly because it's further away. We've also got a couple of dwarf planets in here. So dwarf planets are similar to planets, except they don't meet all the criteria of being a planet. Like maybe they're too small or something like that. So these two here, Ceres and Vesta down here, orbiting in the asteroid belt, are classified as dwarf planets. Further out than that, we've got some of the gas giants. We've got Jupiter, Saturn, Uranus and Neptune. So compare the orbital motions of those planets. They're much further out than Mercury. Mercury is, you can see that it's orbiting much faster than these. These barely look as if they're moving, which is bonkers, I think. They're actually moving much slower because they are much further away from the sun. It does take quite a long time for them to get all the way around. We've also got some more dwarf planets out here. Pluto is probably the most famous example of a dwarf planet. We've also got other planets like Sedna here that's also orbiting, and so on. And we've also got loads more asteroids out here in what's called the Kuiper belt, orbiting around the sun as well. Right, let's go to a planet, shall we? Let's see what's orbiting the planets. Welcome to Mars. I've chosen Mars because it's my favourite planet. You can see that it's got 2 moons. So a moon is something that orbits a planet. It's got 2 moons, Phobos and Deimos. Notice again that the ones that are closer, the objects that are closer, are orbiting at a faster speed. So Phobos is much closer, so it moves faster in order to maintain its orbit. Now, if I were to change the orbit, if I was to make it closer, if I was to bring this closer, let's bring Phobos closer. Edit. I'm going to edit the simulation. So there we are. Move. Am I doing this right? I don't think I'm doing it right. Yes. If I move it closer, you'll notice that, let's have a look at the speed as well. The speed at the minute is 2.11 kilometers per second. So if I let it play again, notice that the speed it increases massively in order to maintain its circular path around Mars. I could actually reduce that back down to its 2.11 mark, and we'll see what happens. Now, because I've reduced the speed, it was no longer capable of maintaining that circular orbit, and notice that it's crashed into the surface of Mars, causing massive craters to form. And actually, for a long time afterwards, we're going to see these fragments of the moon smashing into Mars. So let's recap that then. So around stars like the sun, we've got lots of planets, and around those planets we've got moons. Things that are orbiting closer have to orbit faster in order to maintain their orbit, otherwise they'll crash into the surface like we've just seen there. Yes. So finally then, I just want to look at the Earth-Moon system again, and just go over some satellites. So firstly, we've got the Moon, which is an example of a natural satellite orbiting the Earth. The Moon here orbits the Earth. It's a natural satellite of the Earth. Now, this highly realistic simulation has also included some of the artificial satellites of Earth, things that have been man-made, launched into space by humans. So one such artificial satellite is this one here. So the Great Pyramid of Giza, launched from Egypt about 2000 BC, currently orbiting the Earth as we speak. It's much closer to the Earth, so it has to orbit very fast. I'm kidding, by the way. It's not actually in space. You probably knew that. But yeah. So this. If this was actually in space, then it would be an example of an artificial satellite. I'm just going to change this to seconds every second so that we can see how fast it would be orbiting at this distance. So you can actually see that it's moving. This is probably not too far from where the ISS would be orbiting, which is an example of an artificial satellite as well. Man-made, launched into space. Oh look, it's actually very close to Egypt right now. That's pure luck that that's happened. That's cool. So it's nearly in Egypt. Should we try and make it land in Egypt? Let's try and make it land in Egypt. Let's reduce the velocity. So like I say, it's in orbit at the minute. If I reduce the velocity, then it's going to come back down to Earth. So let's take it to 1 kilometer per second. See what happens. Speed it up. See where it lands. Hopefully in Egypt. Oh, not quite. Oh God. Okay. Yeah. The impact of the Great Pyramid of Giza hitting the Earth at, well, at 1 kilometer per second. Actually, it would have speed up a lot on its way down. So probably quite significantly more than 1 kilometer every second. Has caused quite a large crater in Africa, in the Sahara Desert. So, whoops. That's probably going to be an extinction event for quite a lot of creatures on Earth, I would imagine. Whoops.